All right, the first thing we're going to talk about is the product property. All right, so we're going to do a little discovery with this property, and then I'm going to have you do it. The expression that they give us is 2 to the second power times 2 to the third power. Those have special names, right? So to the second power, we say squared, and to the third power, we say cubed. We really don't have any after that. You just say fourth, fifth, sixth, or whatever power it is 2. So we have 2 squared and 2 cubed here. You know this from like elementary school, hopefully. When you first started learning exponents, it's just that number multiplied by itself that many times. So if we were to write out 2 squared times 2 cubed, it would be 2 times 2. That's the first one. And then 2 times 2 times 2. That's the second one. And you can see then that you have 5 of those. So go ahead and write these 3 out. And then I want it written out here. And then to 1 power right here. This needs to look just like that base to a power. Look back at your table. Did you notice a pattern with the beginning expression and the final expression? What did you notice from the beginning to the final? So when I had x to the 6th times, we'll just put a dot there because my x's are confusing, times x to the 3rd. What was your final answer there? X to the 9th. What do you notice about that? Yeah, your exponents are just adding. So that is actually the rule. If I have x to some power times x to some power, and that x represents any base as long as they're the same. 3 to some power times 3 to some power. 4 to some power times 4 to some power. As long as your bases are the same, the rule is you are just going to add your exponents. That is your first property. When you multiply like bases, you add their exponents. So based on that, let's quickly go through these. If I have 5 to the 5th times 5 to the 6th, what am I going to get? 5 to the... There we go. All right, so you should see that we are just adding. As long as those bases are the same, you are just adding your exponents. Let's look at this one. So based off of what we just did here, we have a power to a power. So we have 4 squared, and that whole thing is being taken to the 3rd power. So what that means is 4 squared times 4 squared times 4 squared. And if we expanded it even more, we would have 4, 4, 4, 4, 4, 4. So we would have 4 to the 6th power. So go ahead and do those 3. We had x to the 4th, that raised to the 5th. What was our final answer? 20, hopefully. All right. So what did you notice about the patterns? Yeah, when you have a base, that raised to a power and raised to another power, that's the same thing as that base, and you multiply their powers. So go ahead and very quickly do A through D using that rule. Power to a power, you multiply. Your book has these two properties listed right there on page 328. The product property says if I have the same bases and I am multiplying them, I can just add their exponents. If I have a base power to a power, I multiply their exponents. This is different than adding and subtracting. In order to add and subtract, you actually have to have like terms. So when you add and subtract, your exponents don't change at all. In fact, they have to be the same in order to add or subtract. But multiply, you can multiply anything as long as they're the like base. All right, so if they're like bases, you're going to multiply. You're going to just add those exponents. And then they give us some examples here. So they have combined these properties here. This is your basic property. We're just going to add those. This is your power to a power. We're going to multiply those. But now we have both properties. And so when you start doing both properties, you have to think of the order in which you need to do those. Before you can multiply like bases, everything has to be out of the exponents. So before I can multiply this y to the fourth and this guy right here, I have to get him out of the parentheses. So I'm going to get him out of the parentheses by doing this multiplication first. So that is going to be y to the fourth times y to the sixth, multiplying that 3 and 2. And then now I can do my addition of my exponents. Those being multiplied, I would add the 4 and the 6 and get a 10. So when we start combining these, then you have to start simplifying them in an orderly fashion, right? Look at the next example. They want us to simplify this. So what you'll notice is different about this and what we have been doing is this one has coefficients. And so when you have coefficients of your variables, you are going to multiply those just like you would. So you're going to say 3 times 5. I can do this because if it's all multiplication, which is what this is 3 times x squared times 5 times x, then I can rearrange them and it does not matter, okay? And so when you have a coefficient and a variable, keep in mind that's just multiplication. So when I have this, I'm going to multiply my coefficients, and then I am going to use my properties to multiply my variables. So for this one, I would have 3 times 5. That gives me 15. And then for this, I have x to the second. And then what is that power on that second x there? If I don't see a power, it is to what? 1. It is to the first power. So I have 2 plus 1. I have x cubed. So really, when I think about this being in parentheses, it's to the first power. So when I just have parentheses around it, I can just ignore the parentheses. If that was some parentheses to a power, then I would have to deal with that first. But that's just to the first power there. So I can think of this thing as negative 8 times x squared times y times z cubed times x times y times z squared. Okay? So I can just think of all of those as multiplication. And I'm going to combine everything that is alike. So this negative 8, I don't have another number to deal with here. So that's just going to stay a negative 8. For my x's, I have x squared and x to the first power. So that's going to be x squared, x to the first. For my y, I have y to the first, y to the first. And then for my z, I have z cubed and z squared. I'll do a different color there. So you can rearrange them so that they're grouped. You don't have to rewrite it. You can go straight to your answer if you start seeing the pattern quickly. But I'm just showing you how you're going to do this. So you're going to end up with negative 8. X to what power then? 3. Y to what power? And z to what power? There we go, and that's my answer. So for this one, I actually have a group within it. So for this one, when I have parentheses and then a parentheses to a power, and I have multiple things within the parentheses, everything within the parentheses has to be taken to that power, okay? So when I look at this, I don't see a number in front, but technically I do have one. I have that guy right there, a negative 1. So you need to think about it this way. I have a negative 1 being raised to the third power. I have an a being raised to the third power. And I have a b squared being raised to the third power, okay? Everything inside the parentheses is raised to that power. So if I have a number, that's easy. Negative 1 times negative 1 times negative 1, that's just negative 1, right? A to the first power cubed, well, that's just a cubed. This one I need to do a property. What property do I need to do there? Multiply those, so that's b to the 6th power, okay? You can leave the negative 1. You don't have to put it. You can put just a negative there. I'll take either one at this point. But anytime you have parentheses raised to a power, every single thing inside the parentheses has to be raised to that power. All right? So let's look at a little more difficult ones. All right? A little more difficult ones here in our book. I have this first group raised to the third power. I have this second group raised to the second power. Okay? So that means everything within the group has to be raised to that power. Before I can start combining the two bases that I have, I need to get them out of the parentheses with those powers, okay? So I'm going to take the negative 2 and raise it to the third power. I'm going to take the m to the 4th and raise that to the third power. And then I'm going to take the n and raise it to the third power. That is being multiplied by this group. This group is being raised to the second power. So I have 1/6 raised to the second power. I have an m raised to the second power. And I have an n squared raised to the second power. Okay? So I'm going to simplify all of those before I start putting my numbers and my variables together. Okay? And we'll talk about that fraction. So negative 2 cubed. Well, that's negative 2 times negative 2 times negative 2. What do I get? Negative 8. Here I have to do my property. 4 times 3 gives me a 12. This is just going to end up being n cubed. Let's talk about this fraction. When I do a fraction to a power, I just do the numerator to the power and the denominator to the power. So here I'm going to say 1 squared is going to be my numerator here. 6 squared is going to be my denominator. So that's how I'm going to take a fraction to a power. I just take each piece of it to that power, all right? And then I'm going to do the same thing here. This is just going to end up being m squared. This is going to be n to the 4th, all right? So clearly I am not done with this one yet because I now have bases that can combine and coefficients that can combine. So when you give these answers for me, you never want to have two of the same variable because you could have combined them with your properties. At this point, we can start combining anything that is alike. So I can combine this negative 8 and this 36. Negative 8 times my 1 over 36, right? I can combine my m's. I have m to the 12th times m squared, and I can combine the n's. I have n cubed times n to the 4th. So now we're just doing our properties, and for the numbers, we're just multiplying. So what can I do with this negative 8 and 36? Does anything come out of both of those? Because remember, it's negative 8 over 1. What can go into the 8 and the 36? How does that reduce? Yeah, 4. So I divide 8 by 4. That gives me a negative 2 on top, right? And then divide 36 by 4. What do I have on bottom? 9. Here, I have like bases. What's my property tell me to do with those exponents? Yeah, I add. So that's going to be 14. And what about the n? 7th. And that is my final answer. When you have one coefficient, one of each variable, you're done. All right, so quotients are fun because they open you up to lots of different properties. The first property we're going to talk about is just basically dividing like bases, okay? Dividing like bases. And so we have right here 3 to the 6th over 3 to the 4th. If I were to write that out, I would have 6 3s up here, 4 3s down here. When you divide, you can cancel 1 to 1, okay? Like 3 divided by 3 is just 1. 3 divided by 3 is just 1. 3 divided by 3 is 1. 3 divided by 3 is 1. So those basically cancel because it's just 1 times that, right? So if I were to rewrite those, I would say, well, that's 1 times 1 times 1 times 1 times 3 times 3, okay? So that's why they cancel. They technically turn to a 1 being multiplied. I say that because if all of your numerators cancel, you need to put a 1 up there. But what that's left with is just a 3 times a 3, which is 3 squared. If I were to do this over and over, I would have 4x's up here, 3x's down here, and I could cancel 1 to 1, and I would be left with 1x, right? So hopefully you're starting to see a pattern. What pattern are you seeing evolve here as I cancel? Yeah, that is my pattern. And so when you look at it, it says, look back, do you notice a pattern? It is yes, we are subtracting our exponents. And that is the rule. If I have x to a power over x to a power, that just means like bases. Then I am going to calculate that by subtracting my exponents. Subtracting my exponents. So very quickly do those 3. All right, so in this case, you'll notice my numerator is smaller than my denominator. So when I apply my rules, 2 minus 6 gives me a negative 4. 4 minus 5 gives me a negative 1. What does that do? Well, if I were to write these out, x times x, and then I have 6x's down here, I can cancel, right? This is why it's important to understand it's changing to a 1. Because in the numerator position, I am left with a 1 because they all canceled out. When they all cancel out, it's just a 1. And in the denominator, I have 4 x's. So I get 1 over x to the 4th. All right? So what you notice is this is 5 to the negative 2nd. And when I write it out, I get 1 over 5 to the positive 2. X to the negative 4. When I write it all out, I get 1 over x to the positive 4. So what do you think is going to happen here? 1 over x to the 10, right? The pattern that hopefully you see is the negative exponent, which is what you get here. The negative exponent actually just puts it in the denominator. All right, so the rule looks like this. X to some negative power is the same thing as 1 over x to a positive power. I will tell you this too. When you get a negative exponent in the denominator, it'll actually flip it to the numerator. Because it's like 1 over, like, so if I have something like this, that's the same thing as saying 1 over x cubed, which is the reciprocal of that. So that's just x cubed in the numerator. So it actually flips it, all right? It'll put it in the denominator if it's not, and it'll put it back in the numerator if it's already in the denominator. It actually flips places where it is. So let's look at this one right here. My first rule is I'm multiplying like bases. So I need to add a 2 and a negative 5. What is 2 and negative 5? So it is negative 3. So how would I rewrite that? 1 over x to the positive 3. There we go. All right? Let's look at this one. This rule tells me if I'm dividing, I should subtract. What is 6 minus 12? Just negative 6. So how would I write that? 1 over 5 to the positive 6, right? The rule applies even if you have a power to a power. What is negative 2 times positive 9?
Negative 18.
Yes, and so I'm going to rewrite that guy as 1 over 8 to the positive 18. That is my negative exponent rule right there. Okay. This always confuses people. People always want to tell me that something to the 0 power is 0. It is not, okay? Let's look at what we have here. We have 5 squared over 5 squared. My rules tell me to subtract those exponents. Well, 2 minus 2 gives me 0, all right? So let's spread that out and look what that actually means. I have 5 times 5 over 5 times 5. There's 2 ways to look at it. You could say that's 25 divided by 25. What is 25 divided by 25?
1.
It is just 1. Or if I were to use my cancellation method, I would get 1 times 1 on top and 1 times 1 on bottom. So anything to the 0 power is going to equal 1. Not that number to the first power, just the number 1. It simplifies to just 1, okay? So that means if I have this guy right here, that's 10 to the 0. 10 to the 0 equals 1. If I were to write this, like say I have x to the 0 times 3. X to the 0 is just 1. So that's actually 1 times 3. My answer here is just 3. So it simplifies to the number 1, not to the exponent of 1, okay? There's a difference. So the rule here is any base, it does not matter what it is, to the 0 power equals just 1. That is your rule for that one. So let's look at the properties in your book. All right. This is on, 333. The first property is you subtract your exponents. This example here. So when I have something like this, I'm actually going to write it like this. All right. When I do this, I can reduce the numbers just as though they were their own fraction. Okay. So does 32 over 4 reduce? Yes, they actually reduce by 4. So I'm going to end up with just an 8 up here. Okay, just an 8 up here. Then this is a cubed over a to the first power. So my 8 over 1 is how that first guy reduced. 8 over 1 is how my numbers reduced. And then I'm going to look at reducing these. Well, my rule tells me if I'm dividing, I need to do this. So I have 8 over 1, which simplifies to just 8. And this should simplify to just a squared. That's my answer. I told you they get bigger. Okay? So what I like to do when I'm first learning how to do this is I like to actually set up individual quotients, all right? So like I would take my numbers, my 24 and my negative 8, and I would write that here. And then I would take my x's. On top I have x squared, and on bottom I have x to the first power. Then I'm going to take my y's, y to the 6th over y squared. And then I'm going to take my z's, z to the 7th over z to the 5th. When you're first learning how to do this, this is a good way to just break it up so you're not overwhelmed by what you're looking at, okay? And so then it's pretty simple. This simplifies to what? What is 24 divided by negative 8? Just negative 3. My rule tells me to subtract 2 minus 1. I have x to what power? The first power, yep. This tells me to subtract 6 minus 2. I have y to the 4th power. Z is 7 minus 5. I have z to the 2nd power. So don't let it overwhelm you. Take it a piece at a time and separate it out if you need to. All right. So when I have things like this, I am just going to simplify each piece. My first one is x to the negative 4th. Well, how would I rewrite that? That is going to be 1 over x to the 4th. And y to the squared doesn't really do anything. So the most simple way to write this is to say y to the second over x to the fourth. Okay? So it just shifts where it is. Let's look at the next one. My 2 is not being taken to any power. Okay? That power only applies to my x. So my 2 stays where it is. My x goes into the denominator position. All right? Let's look at this next one. Before I can even think about what's going on as far as my exponents on the inside, I need to do that exponent on the outside first. So I need to say that is negative 3 cubed, and that is x to the negative 2 cubed. So I want to do all of that first. That negative 3 is just my number. It has nothing to do with the exponent. So I'll just say negative 3 times negative 3 times negative 3. That is negative 27. And then I multiply these. Negative 2 times positive 3 is negative 6. I don't ever want to leave a negative exponent. So I'm going to rewrite it. My negative 27 isn't even being taken to a power, so it stays where it is. The x is to a negative power, so it goes on bottom. Okay? It goes on bottom. And then the final one here is a little bit different. It's a fraction. So we're going to do the same thing that we did with this first one, this one we just did. We're going to say 1/3 to the negative 2, and then x to the negative 3 to the negative 2. All right? So let's look at this first one. 1/3. Anytime I put 1 over a number, I'm technically taking the reciprocal. So if I said, what is the reciprocal of 5? You would say 1/5, right? So that negative exponent puts it in the bottom, but technically what it's doing, it's taking the reciprocal of it, okay? So x to the negative 5th technically means the reciprocal, 1 over x to the 5th, okay? So with this fraction, I have 1/3 to the second power. I need to flip it and take it to the second power, right? Because right now it's to the negative 2. So I'm actually going to flip this 3 over 1, and I'm going to take it to the positive second power. It reciprocates it. That's what that negative exponent has been doing. And then here, I actually take care of the problem in my multiplication. What is negative 3 times negative 2? Positive 6. So I actually end up with no negative exponents here. I just have 3 over 1, which is just 3 squared. So this part is just 9. And then I have x to the 6th there. All right. So when it says divide, I'm going to take piece over piece, okay? Normally you're going to see it written like this. 34 x to the negative 3, y squared, z to the negative 5th, over negative 18, x to the negative 6, y squared, z to the negative 2nd. You're going to see it written just like that, okay? Break it up. We have our numbers, 34 over negative 18, okay? Then we have x to the negative 3 over x to the negative 6, y squared over y squared, z to the negative 5th over z to the negative 2nd. We're going to take it a piece at a time. What goes into 34 and into 18? 2. What do I get? On top I get 17, right? Over 9. Yes, if I divide both by 2. My rule for my x's is negative 3 minus a negative 6. We'll come back to that. Y is going to be 2 minus 2. Z is going to be 5 minus a negative 2. Okay? So that's what I mean by take it a piece at a time. Here we go. My red is not going to reduce. I'm done with that guy. What is negative 3 minus a negative 6?
Positive.
Positive 3. What is 2 minus 2?
0.
0. And what is 5 minus a negative 2? 7. All right? And this guy didn't change. There's a couple ways you can write this. First of all, my y to the 0 is just anything to the 0 power is the number 1. Okay? So he's not going to change anything. You're multiplying things by 1. Doesn't change, all right? I have negative 17 ninths x cubed z to the 7th. That's actually my answer there. If I had anything on the bottom, I would have had 17 on the top, 9 on the bottom, variables on the top, variables on the bottom. But I didn't have any variables that ended up on the bottom. So that's what I mean, take it a piece at a time. Separate them out by your variables and then simplify each variable individually.